All right, everybody. I think we're live. So I'm going to minimize this. And welcome to week 5 of Summer of Shipping. So can you believe it? It's already, this is our 6th presentation because we started at 0. So it's crazy to believe for me, but yeah, here we are. So, whoops, I forgot to full screen this. 1 second. Full screen. All right. So last week we talked about 30 days of shipping. That was the main kind of announcement. And we also focused more on demos, and I think that was a lot of fun. I think moving forward in the future, it'll be more like that. It'll be more of a demo-focused thing, but that was what we did last week. This week, we are going to talk about communication and Docker. Those are communication as a soft skill and as it pertains to some observations I've made so far with summer shipping. And then Docker, just the technology Docker, which Nick is going to talk about. And before we do that, what we're going to do is, as always now for each week, is give an opportunity for people to pitch their projects. And so if you want to pitch, if you are looking for additional team members, get that queued up. You'll get a second in maybe like 20 seconds or 30 seconds or so after I read off the objectives as a reminder. So if you want to pitch, just make a comment in the Zoom chat. If I don't see anything, we'll just move on. So right now, just if you want to pitch, add a little thing in the Zoom chat and we'll make a little pause and let you pitch and then we'll move on. So that's that. So refresher for our objectives. As always, we have 2, so we've got at least 1 pitch. All right, so objectives for the summer, there's 2. One of them is to improve your resume. The second one is to improve the skills you need on the job. So as always, the traditional resume will be improved by the project that you guys ship. So when you guys are thinking about that, if you are at a hackathon, you reverse engineer the demo. You're here at Summer Shipping, and one of the objectives is to reverse engineer your resume. So get a sense for what that might look like after you're done with what you do this summer, right? The other thing is your public resume, and that's being useful and interesting on the internet. That's to increase inbound interest into people like just finding your projects as well as potential collaborators down the line, which could be employers. And then finally, to improve the skills that you need on the job, we're going to talk about things like code quality communication. These presentations are meant to help a little bit with that. They're not meant to be where the bulk of the work happens. That's going to happen on your projects and via mentorship. But that's kind of what we're going to do. So today, we're going to talk about communication. So that's we haven't really talked about it that much in the past. Just talked about a little bit in the project management meeting, but we haven't talked about it explicitly. And another thing we're talking about is Docker. So that's what we have coming up today. All right, so I saw somebody want to do a pitch, so I'm going to pause now and let them pitch. So first up, we've got Jack, and then we'll have, is it Jaidev? Go after that. So why don't you guys take it away? So just unmute yourself, and you guys got basically a minute, and I will try to let you guys know if you're running over. So turn it over to you guys.
Hey, Summer Shipping, Jack here, on the Python group team, and we decided we were going to build a web recipe app that will provide healthy recipes based on what you have in your kitchen. If you are interested in joining our group, I put a link to the Google Doc with our plans and documentation for the app in the Find a Group channel. Thanks. Awesome. Hopefully you can join us. Thank you.
Awesome. And Jack, can you give a quick overview of the technologies and how many people you have?
Yes. So we have about 5 people right now, and we will be using Python, Django, Flask, and React.
And are you guys trying to get to 1 additional person, or maybe?
We're looking for anybody who will be active.
Okay, gotcha.
As many as possible.
Okay. Yeah, and one thing I do want to caution with that is if a group gets too big, then it's kind of it can be hard to manage. But there's one thing that we can always do is we'll need a little bit more guidance on the project management side just to make sure that people are not stepping on each other's toes too much or something along those lines. But awesome. So thank you very much, Jack.
Thanks, Phil.
And reach out to him in the channel. Next up, we've got I think Jaidev. So when you're ready.
Sure. Hi, everyone. I'd like to pitch on behalf of YouTube NLP. We're building a dashboard where you can run all sorts of NLP analyses on YouTube videos, and more specifically transcript and comments. We're looking for 1 or 2 more Node.js, preferably, but like backend developers. We currently have 6 people, one of whom is a product manager and 2 mentors already. Our stack looks like React and a combination of D3.js for interactive visualizations. Node is like the current plan for the backend, and we'll be using Python for all of our NLP stuff. So we have NLP and front end pretty much covered. We need a little bit more help on the backend side.
Awesome. Thank you very much, Edev. All right. So if you're interested in joining either of those projects, I think Jack mentioned that there's a link to his in the idea pitch channel. So you can take a look at that. And I think both projects are on the project tracker. So,
oh, and sorry, quick note. I'll
yeah.
post a description and a link to our scope doc in the chat for anyone.
Perfect. Awesome. So there you heard it here first, guys. There's a few openings on these projects. So if you want to hop aboard, definitely reach out to the project leads out there. All right, cool. So with that, I don't think there's anybody else in the Zoom chat. So we are just going to go right into the Milo portion of the presentation. So communication. We're talking about communication. It's a massive topic. But right now, we're going to talk about communication in regards with communicating with your peers this summer and communicating with mentors, because that's kind of where the bulk of the communication will happen. There's other forms of communication that you need on the job, such as communicating with your manager and communicating with even higher ups and kind of more laterally across teams, product managers, all that stuff. We're not going to get into that. We're just going to talk about how it pertains to summer shipping right now. So communication with peers. There's a couple of things I've seen so far that have been, I think, creating friction and just how people assemble. So the first is a problem of unresponsiveness. So sometimes people will reach out and they'll hear back from a teammate maybe once or twice, and things are going really great, and then all of a sudden silence. And this has happened many times, and I think I have a few reasons for why I think that's happening. But then there are also, on occasion, teammates will be really active, and then suddenly they just kind of vanish. And it's not clear what's going on. So unresponsiveness, there's many reasons why somebody might be unresponsive, but that's something that we want to find a way to address. Another thing that oftentimes happens is people are actually working. They're actually doing their part, but they're not keeping people up to date. So work is getting done, but no one knows about it. And I'm guilty of this myself. I do a lot of work and I don't update everybody with what's going on in summer shipping. And so if you're part of the moderator team or the growth team, you've probably been frustrated with me on that. So I'm not perfect. But sometimes people are feeling like they're getting left out. And there's some things that we can do to make these processes a little bit better. And so we'll talk about that. So here are some suggestions for communicating. The first one is just creating some recurring communication channels. One of them is if you have a project server, setting up a daily stand-up channel in your Discord. You don't need to do this daily. It can be Monday, Wednesday, Friday. It could be even just Tuesday, Thursday. Preferably maybe 3 times a week is a little bit better. But the idea is it's a recurring communication channel where everybody knows, hey, on this time of this day, I will have an update from X, Y, and Z on just what's going on. And so it's just a heartbeat of the project from the perspective of somebody else on the team, just to make sure that everything is going well. In my own Discord that I'm running for the Summer Shipping Showcase project, I just had Ken set up this channel before I realized that I had permissions to actually create my own channel. But we did that, and I hopefully that will help create that recurring communication. And it's just really important to have those regular progress updates, so everyone knows that you're still at least alive. And that's going to be a useful way to just keep that combat unresponsiveness. Another thing is what we're doing with 30 days of shipping is actually really important, and it's one of those things where on the job you have daily stand-up, but if you're working solo, you may not have anybody keeping you accountable, or you might, but it's like it might just be one friend. And so what you're doing with 30 days of shipping is you're putting yourself out there, putting yourself on Twitter, and now Twitter gets to be people that engage with you and give you support as well as some feedback. And so you can be accountable, and you can almost like turn Twitter into your manager in that sense. So it's a very important on the job skill to have these frequent updates so that people kind of have a sense that, hey, you're not isolated, you're not struggling too much on one thing. Another thing that I've seen is expectations. So people aren't oftentimes upfront with how many hours per week they can put into the project. So one suggestion I have is, hey, when you all meet together, say like, hey, I can make a medium-sized contribution per week, and maybe that's like 10 hours a week. The numbers I put on the slide aren't that important. It's just that you need to find some sort of expectation setting with your team. And if you haven't set those expectations with your team, now would be a good time to do it. So set those expectations. It'll help everybody just kind of get aligned with what, how much work is actually going to be done by whom. And the last thing is focus, like push more towards asynchronous communication. So decisions are best made, I think, on GitHub issues or some sort of issue tracker. Maybe it's Trello or whatever. Make an entire card for that or issue for that. And you can talk about it during Discord, and Discord is great for the back and forth real time, but it's not so great for figuring out what happened. And somebody had, when they look at the aftermath, it's really hard. So try to make these things asynchronous. And where possible, minimize synchronous meetings. Try to get rid of as many as possible. 1 a week is fine or so, maybe even 2 a week, but try to minimize them as much as possible. And anytime you do a meeting, try to have meeting notes, or even better, record the meeting like we do with these ones. So the other thing I want to talk about is communication with mentors. And the first one is people are not reaching out as much as I had anticipated. And I think part of this is a awareness problem. Not everyone is familiar with the mentor list. So if you go to this URL, you can see the roster of mentors who've made themselves available. There's actually more mentors who have signed up, but they haven't yet put themselves on this roster. But these are the mentors who are available, and you can contact them and reach out to them. And there's oftentimes link to their LinkedIn and also their background, so what they can help out with. The other thing is people oftentimes, even if they found a mentor for their project or whatever, they may not be asking for help. And so they're struggling in isolation for too long. And this is a huge failure pattern for lots and lots of junior engineers and interns. And so this is something that I expect to happen over the summer, but one of the things is to encourage this to not happen. And so I'm going to tell some stories about that. And a big part of why I think communication with mentors is also hard is reaching out can be scary. And so let's talk a little bit about kind of fear and what might be holding people back when they're reaching out to mentors. So one of those things is fear of looking stupid. And fear of looking stupid is something that is really, really, really important in this industry. So whenever you're learning a new technology, you're not going to be the best at it. And so guess what? You might feel stupid. If you're joining a new company or working in a new domain, maybe you just switch teams, well, that's going to be a lot of new stuff, and you may not be a master of it, and you might feel stupid. A professional engineer is always learning new technologies, constantly changing domains from team to team after one successful project to another successful project, and sometimes even companies. So therefore, a professional engineer is a professional at feeling stupid. This is a quote from one of our mentors, Kevin, and he had this to say. He says, "We're all just engineers, and it's really hard to convey that our expertise is really just time in the field, not some magic, unachievable talent. But a lot of interns think that way and are really afraid of making a bad impression. It's important to make sure that they see that I'm just as valuable as anyone else." So I really love this quote because what he says is expertise from far away looks like expertise, it looks like magic. When you zoom in, it's just time in the field. And so, okay, let's zoom in on this. So expertise is just time in the field, right? So what does that really mean? It means time spent feeling stupid, working at it either quickly or slowly, sometimes slowly, and then eventually succeeding. And that's what magic looks like from far away, right? I've got some chats that so some people are also commenting on this. I'll look at those a little bit later. But so this is where expertise comes from. And then the secret ingredient is a lot of expertise comes from help from others, and it's hard to see that. So feeling stupid is normal. And let me tell you a few stories of when I tried to avoid feeling stupid when I was just either in college or when I was my first year as an engineer. So in college, those who watch the kickoff know that I did not graduate with a CS major. I graduated with an econ major. And at some point in college, I was actually considering, maybe could I do a CS major and switch my major from econ to CS? And the answer was just no. And the reason for that is I did not ever learn how pointers worked. And this is ridiculous, right? Like if you have been in engineering for a while and you use language like C or C++, it's like almost an unavoidable aspect of language. I programmed in Golang at Uber, so I had to know pointers. But when I was in college, I almost quit because I didn't know how they work. And one of the things that I heard, or some like a college professor, maybe one of mine or something that I had read on the internet, basically said, if you can't learn pointers, you can't learn computer science. And I, for some reason, let that affect me, and I kind of just gave up, almost gave up. But then later down the line, I was able to figure it out, and it clicked just really, really easily. And I realized, whoa, this entire time, this was not some complex thing. I was just getting confused. So I tried to hide that for a while, wasn't out in the open about it, and it almost made me feel like I wanted to quit. So that was my first experience of avoiding to feeling stupid. The next time, another time I want to talk about is a big project I was working on my first year. And I was trying to hide my spaghetti code from my mentor. So he sat next to me, and he was awesome. A guy by the name of Evan Jones, and one of the best engineers I know. But like, I was working on this project, and I was going to send it over to him. I kept on telling him I'll send it to you, but I just really didn't want to show it to him. And I kept on adding more stuff to it, and this code review got massive, bigger and bigger. And by the time I sent it to him, it was it was a disaster, and it took forever for him to code review because there's so many things. And by the time like we're trying to get through code review, the team was like, okay, it's not that important. We don't even need this. It's not that like major of a product. So let's just scrap it and get you working on something else. So that was really unpleasant. Other time I pretended to know promises, and I wrote a bunch of really stupid code that didn't properly handle promises and didn't catch the errors properly. Yeah, that was not that great. But then the thing that I hid for the longest time at my first year on the job was I pretended to know how to write unit tests in Java. And and this was kind of funny because I didn't want to let anybody know that I didn't understand what Mockito was, right? Like, somebody gave a presentation on Mockito one time, and I was just like, oh yeah, totally, that makes sense. I had no idea. I didn't know like what mocking was. I didn't really understand why we needed to use this Mockito thing. And anytime I had to write code that had unit tests, I would avoid it. And so I did that, and that held me back a lot. So doing all these things held me back, and it's all because I was trying to avoid feeling stupid. But now I shamelessly embrace the feeling. And so, because I know it's part of the job. So one thing I first do is I seek out multiple sources. Remember the pointers, like that was just the fact that I didn't have the right source for me. And so now YouTube is really great. There's so many blogs out there, and you can, if you don't understand something's not working for you, there's oftentimes another resource that can. And so that's where I start. But then what I do is I reach out to engineers on my team who are more knowledgeable about something than me. And that's something that I do, or maybe not to this day, but when I was, still working, is I would still reach out to like leverage the team, and I would reach out. Sometimes there are people who are younger than me, and that's what I would do. So, and now finally, the big evolution for me is now I speak openly about not knowing something. There are things like if I ever get caught up in something or whatever, I'll just tell people straight up like, hey, I don't have any background in that. And that's just something that I'm openly like able to admit, and I feel comfortable doing that. So takeaways from my section of this talk: err on the side of over communication. So create those stand-up channels. Share your availability so that you don't go dark for 1 or 2 days or something like that. Maybe you are going to be gone for the weekend, or you're going to be unavailable for 5 days or so. Let your team know. That's going to be really important. If you are working solo, participate in 30 days of shipping hashtag on Twitter, because that will kind of allow you to create this communication. It's accountability to yourself, as well as a way to get feedback and people to kind of participate with you. So it's really important to communicate on the job. And so the more you practice this summer, the better you'll be at it on the job. It's just going to feel more natural. It's not going to feel weird, because it does kind of feel weird at first. And then it's better that your teammates know too much about what you're doing rather than too little. So just think about it like that. With expectation setting, number of hours per week that you will commit, just make that clear. If you guys haven't done that yet, now's a good time to make that clear to your team. And your skill set. You probably have already done that just because it's pretty obvious what people are going to be working on. But just make it clear, hey, I have almost no experience with X, Y, or Z. Or like, hey, I know, like for me, like, hey, I know that, I say I can do CSS, but really my CSS is crap. I once, like, I was interviewing at a full stack role one time, maybe right before I got my job at Uber. And one of the interviews was like, it went really, really, really well. But then the only thing that they were like was like, whoa, you did really well, except we hit a snag on your CSS basically. And it was like, oh, okay, well, All right. And so I'm not the best at CSS, and that's one of the things you want to communicate, right? So the other things in terms of feeling stupid, hey, feeling stupid is 100% normal. It means you're learning. Mistakes will happen. Bad code will happen. It happens. All right. The way to get past this, try on your own first, but don't feel bad about asking. One of our mentors have a really great way of getting past this. He says, what you can do is time box it. So take a task, look at its easy, medium, hard, and say for easy ones, I'll give it 2 hours, medium ones 4, hard ones maybe 8 hours. I'll try it. If I finish it by myself, that's great. But if I get stuck after this time box, I'll ask. And that's a really great way of making sure you don't get stuck on something forever. And remember, our mentors are here to help. Now, nobody is forcing mentors to show up. No one's forcing anybody to do anything. We're all here because we want to help. So just think about that. And think about this. The risk to reward ratio is heavily skewed in your favor if you ask. So if you put up a tiny bit of courage, you may receive a wave of support. And the downside is basically zero. So just think about that. The risk reward is so much in your favor right now. On the job, there might be a little bit more downside, right? People might think you're actually an idiot, and that might not be good for you. But here, like, doesn't matter. So that's kind of what I want to encourage, and that's the tone that I want to set. So with that, my portion of this presentation is done. And the action items that I want you guys to remember this week, just every day ship in Joom. That's the main action item. And for groups that just formed, make sure you go and find yourself a mentor, reach out to mentors, DM them on Discord or book time on the Calendly, see if they want to be a project advisor, if they can help out in another capacity. Some mentors may only be able to help out a little bit because they might be helping other groups or something, but just make that clear, set the expectations, right? And once you've got all of that ready, be prepared to demo something next week. You don't have to demo next week, but just be prepared. So with that, I am going to stop my portion of the presentation and I'll turn it over to Nick. I think I went a little bit over, but stop sharing.
Hey all. Let me apologize in advance if my connection drops because it just dropped a minute ago and I'm not entirely sure why. So I sent the slides to Phil if maybe my connection drops and he can possibly pick up from where I leave off. But can everyone see my screen? And where is the present button? Okay. So yeah, I wanted to talk today about Docker and containers. And yeah, there's kind of like two motivations for why I wanted to talk about this. One was just that the number of you had kind of voiced interest in hearing about it. And then the second was kind of personal on my own part. And it comes from when I first kind of entered the industry. I had I guess a bad case of imposter syndrome. And I didn't even know that term at the time, so I wasn't quite aware of it. But there was like, I got to the job and I didn't understand, or I felt like I didn't understand probably 80% of what my coworkers and like managers were saying. And looking back on it in retrospect, like most of what they're saying boiled down into 3 spheres. And the first sphere was just kind of like large company jargon and like how large companies operate. And coming straight out of college, I had no idea how large companies operate. And so that left me a little bit like scared. And the second sphere was kind of, we were a payments team. And I mean, I had no prior experience in payments, and payments is kind of this like arcane legacy system. And like, there's so much stuff there that's kind of like, I had no idea what people were talking about when they were talking about payments. But the third sphere had to do with like computers. And the big project when I got there was that we were Dockerizing one of our major systems. And so I'd be sitting in meetings and the senior software engineers are talking about like Celery and Redis and these task queues and workers and how all these things are going to communicate with one another once they're in containers. And like, I had just come off of 4 years of college, like a CS degree, and I didn't understand what they were talking about. And so I was like, what, like, how do computers work? I don't quite understand any of this. And so those 3 things kind of left me with a huge, a fairly big like imposter syndrome case. And so what I want to do in this talk is help like demystify what Docker and containers are, such that if you run across it in your own projects or at your own internships or jobs, like you have at least a mental model to kind of like hang these terms on. And this will hopefully make it easier to understand and pick up. And so with that, what is the problem? So it's generally good to like first try to understand a problem before you start looking at what the solution is. And the problem here, I'm going to set up a little bit of a contrived example. So to explain like why Docker and containers are helpful. And so this example starts with a team of engineers, and we'll just call them Alice, Charlie. And their team, they're working together. They have an idea they're excited about, a repo set up, and they're ready to go off to the races. And so Bob, let's say Bob decides that he will scaffold the app, and he'll get kind of Hello World version working for Alice and Charlie, and then they can pull his Hello World version and start working. So Bob starts hacking away, and let's say like within an hour, he gets Hello World running on his laptop, and everything's looking good. So he pushes the commit, and he tells Alice and Charlie to pull the commit and try running it, so they can start making changes. And they pull it, and they try to build and run, and then immediately, boom, it crashes with some cryptic error message that they can't quite figure out like what's going wrong. And we have a situation that kind of looks like this, where Alice and Charlie can't get the application to run, and they're like, Bob, you know, what the hell? And Bob is basically running on my laptop. It must be something you've screwed up. And so Alice and Charlie are kind of, I don't know, everyone's frustrated by this. And but not to be deterred, Alice, you know, says she's going to fix the problem. And so she starts making some changes, and she starts inspecting the code, and it's, you know, it's good, straightforward code. It prints hello world, and it makes sense. But there's this whole config part that doesn't really make sense to Alice. And so she starts kind of pulling that out, and she puts in a config that makes sense to her. And she's able to get the hello world application running on her laptop. And so problem fixed, everything's good. And so she tells the other two and pushes her code and tells them, hey, like, check out this fix I pushed. And everyone's excited that the problem is now fixed. And then they try running it, and boom, we have this problem where now Bob and Charlie can't run the application. And Bob's like, you know what the hell, you broke a perfectly good application. And Alice is like, well, it's running on my laptop. It must be something you've screwed up this time. And so this is kind of the situation that's happening. And the main question is like, what's happening here? Why is the application only able to run on one person's laptop and not the other two? And it turns out like there's a key bit of information that I've been leaving out of this explanation so far of the story. And that is that each of our three developers is using a different operating system. And so Alice, let's say she's running on her like brand new 13-inch MacBook Pro, and Bob is running on his home-built gaming PC that kind of doubles as a you know, hackathon machine. And Charlie is using this Linux thing that Alice and Bob don't quite understand, but you know, it has something to do with penguins, and Charlie can just kind of handle his own problems. And so the real problem is that getting a single application to run, or one application to run on all three of these operating systems, can actually be pretty hard and come with its own set of challenges. And that's the problem that they've been running into. And the reason why it's hard is that each of these different operating systems provides a different environment for the application to run in. And by environment, I just mean all the software and all the packages and everything around the application that's running. And this can be things like software you've downloaded, other programs that are running on your machine, permissions that the logged in user has, and so like what permissions they have, and all sorts of things kind of make up the environment or the runtime environment that the application exists in. And the environment can be dramatically different between machines and even like individual people's laptops. And so a general rule, or I guess general observation, more so than a rule, is that like what runs in one environment may crash in another. And I mean, almost every developer I know has run into this at one point or another. And most people run into it in their like first week on the job or their first week on a new team. And what typically happens there is like you'll join a team, someone gives you a URL to like clone the Git repo from, and you pull the repo and you open the README and you start following all the instructions. And then at one point you hit an instruction that you just like an error gets thrown in. It's super cryptic and you can't make sense of what it is. And the reason why that happens is that when the developers set up the application, there is usually some software that supports that app that had just already been installed on those developers' laptops, and they've even forgotten that it's there. And so when they were giving instructions to sort of get the whole thing running, they just forget that that's like a dependency of the application, and they forget to sort of add it as an instruction to download it and install it. And that happens quite a bit. I've run into a couple of scenarios myself, and it can be rather frustrating because you feel like it's not your fault. You follow the instructions, and you're also afraid to ask for help because it seems like, you know, just getting this running should be the easiest thing to do. And yeah, it can be quite a frustrating experience. This was an obligatory XKCD I had to share about Python environments, because the longer you work with Python, the more your environment starts to look like this. It's just kind of what happens. And so it can be quite a pain to solve some Python environment problems. But this isn't even limited to teams as well. Like the solo developers can run into this issue as well. And the reason why is that often when you're a solo developer, like you develop on a laptop like this, but you may deploy your app to this. And the runtime environment between like your laptop and a server on AWS, those can be dramatically different and can have totally different software running. And so like while your app runs on your laptop, it can be quite a different challenge to get it to run sort of in production, so to speak. So what's the solution? Well, the main challenge is just how do we reproduce environments? Is kind of the way I think about it. Like it's really hard or sometimes impossible to reproduce like your development environment and your laptop on someone else's laptop. And so what we do, or I guess containers try to solve this problem for us. And I didn't pull this definition from anywhere, so someone may be upset by this definition if it's not correct, but it's just kind of the way I like conceptually think about it, is that the container gives you a configurable and reproducible environment to run your application in, regardless of the underlying operating system. And that's just kind of how I tend to think about them. What does that look like? For the most part, you have an operating system that is running real close to your hardware, and there'll be an application, this red box, running on your operating system that's an application just like any other, just like Chrome or Mail or Notes or something. It's just something you can download and run. I just think of this as the coordinator, and then you can tell the coordinator, hey, run this container for me. And in that container, you've included your app and all its dependencies and all the environment variables your app needs to run. And the coordinator will spin up sort of a protected environment for your app to run in, sort of away from the operating system that is running on the rest of your machine. And so what is Docker? Docker is kind of, well, Docker was the company that really popularized this pattern for the most part. They launched in 2013, and there are a number of other services and open source projects that offer like very similar functionality or more or less functionality. But Docker is just kind of the big one that most people run across. As well. And so Docker is really, from Docker, you can download this application called Docker, and you can run it on your laptop. It's just an app you can launch, and you can give it containers to run. And it's, so if Alice, Bob, and Charlie had Docker, they could have containerized their application or wrapped their app in a container, and it would have provided them a reproducible environment that they could have all sort of set up and reduced like a whole set of problems for all of them, such that they would only then have to worry about like the app itself, and it removes having to worry about the surrounding environment. So then the next question is just like, how do I Dockerize my app? It's really quite simple. There's 3 kind of high-level steps, and the first step is you need a Docker file, and I'll explain a little bit what that is in a moment. This screenshot on the right is a Docker file, and then you build an image from the Docker file, and then you can run a container from that image. And so what are these terms? A Docker file basically contains instructions for building an image. that may not be of much help if you don't know what an image is. And so an image is a template for creating a container. And the container, which we've kind of talked about so far, is the actual environment, or the contained environment where an instance of your app runs. And so those are kind of, I don't know if these are the proper definitions, but again, these are just like how I tend to think about these things and conceptualize them. And so the sort of pipeline for a containerized application is like this: Docker file, and you call build, and then you get an image, and you can call run, and then your application is running inside of this container. And so one of the last things I want to mention is like, why is there this image step here? Why not just go straight from Docker file to container? And the reason why is that there's, I guess, a couple of reasons, but one, like the build process, move from your to an image, your Docker file to an image, can take a while. It can be like not a super long time, but like it's longer than going from the image to actually running. But the other reason is that the image kind of serves as a snapshot, or a snapshot of a build of your application. And so what people will often do is they create what's called an image repository, which is a lot what it sounds like. In the same way that you have a repository for your code, you can create a repository for your images. And what people do is you can create an image of your application, push that image to your image repository, and then you'll typically have a different system that pulls the latest image you pushed and goes and deploys it to production. And you can deploy multiple containers from that single image that you pushed. And so it serves as a way to kind of version builds of your application. The two kind of biggest image repositories are Docker Hub and Amazon ECR, Elastic Container Registry. They name everything so frustratingly, but those are the two big ones. And so that's kind of, I have a demo if people are interested in like seeing a Hello World application Dockerized. But that was kind of the presentation. I don't know whether to take questions now or like during the demo or after. So,
why don't you start the demo, and then we can take questions maybe during or after if the questions are pertaining to the demo. If not, then we can chat.
Okay.
Afterwards.
I can't see the chat, so you may have to interrupt me if someone asks a question.
Will do.
So you can all still see my screen?
Mm-hmm.
Okay. So here for the demo, we have a little Go application. It's very, very simple. It basically, it's an HTTP server that's listening on this path, just kind of the root path. And whenever a request gets sent to this path, we're going to run hello world. And this just prints out HTTP status code 200 and hello world. And then, we basically set up the server. So from an environment variable called port, we're going to grab the ports that we're going to run or serve our application on. And there's just a print statement. And then we listen and serve on that port on the machine.
And Nick, can you explain what an environment variable is?
An environment variable is basically, that's a difficult question. How do you answer that? It's a variable that's like set up, in my mind, at like the operating system level. So it exists across your machine. And like their environment variables, I believe it's like go path. No, maybe not. Go home. Oh, sorry, I misspelled home. Okay, well, you can create environment variables by doing stuff like this. And so this will be, I can demo an environment variable. Let me try to run this application. Oh, sorry, I'm in the wrong directory. That's, go run, may not go. And so I haven't specified the environment variable, and it's going to panic out at this point here where it's like, I haven't specified a port to run on. And so the application fails. But if I create an environment variable, let's say I run this application on 8080, this creates a variable that if I run the application, it's going to read that variable that I've set up, and it will run the application with it. Does someone else have a better description of environment variables? I don't have a...
Yeah, I don't really have a great one either. I would just say they're just kind of like think of it as your app can reach into the environment variables and just pull out these variables. So it's a way to kind of pass like values across just like processes and stuff.
Yeah, that's a good point. They're shared across processes. So if I were to go to some other process and run this app there, it could read the same value from the environment variable. But so this is kind of the app, and it runs. But now, how do we wrap it in a container? And so if we go to step 1, we need a Docker file, which is here. And we can just run through these instructions real quick because they're pretty simple. The most complicated instruction is this first one. And what this is saying, from Golang :latest, it looks kind of cryptic, but all it's saying is that other people and other developers out there have made images that you can build your images off of. And so the Docker community has actually created an image called Golang here that you can use, and it comes pre-installed with a Linux runtime environment with Go installed in that runtime. And so I can base my image off of that one. And then I have some other like special custom commands for my own app, but I'm going to base it off of that kind of core. I want to run my app in a container that has Linux, and I want that container to have the Go programming language installed in it. If that makes sense. And then these other commands here, I guess, are saying to expect a build parameter or build argument called port. Just assign whatever value that you pass in when you build to port. And then this command is just using that variable to create an environment variable within the container called port that our app is then going to use in main. And then the next command here just kind of creates a directory. And this command copies all the code into the directory. So it's literally just like, okay, now that you've set up this environment for the app, like pull the whole thing in there. And this changes the within the container, changes the working directory to that demo directory we've created. So it's like a CD, like change directory into demo. And then this is just the basic Go command to build the application and then to run. And so to use that Docker file, we would say Docker build. We can pass a build's arguments. I actually have this
Yeah, Rachel Ray it.
Way back here. Okay, so we have, let me change this. So we're going to pass a build arg to Docker build called port, and it's going to have the value 3000. This is just specifying the Docker file to build from. And then we're just going to tag the build as sauce Docker demo. The period is just kind of current directory. So we run that. The first time you run this, it will take a while because it has to, specifically this step will take a while because it will have to pull that image from the Docker Hub here and so then like build your image off of. But because I've already run this before, it's all cached. And so this runs like very quickly. And then if I want to run, well, actually first, let me show the image itself. If I run Docker images, I can see the images that I have on my laptop. This is from a different project. So I have like an image of a MySQL instance. I can just like spin that MySQL instance up at any point. This is the Golang image that our Docker demo image was built off of. So then Docker run, I'm going to need a port mapping. I'll explain what that is in a moment, but don't worry about it too much. We just call Docker run, and then our application is running. And we can send it running inside a container. And so we can send requests to it like this. Hello world.
Hello world running on Docker.
Yeah.
What do you know? Yeah. Hey Nick,
But
what happens if you you're gonna do it anyways. But what happens when you take away that port mapping?
if I take it away, yeah. So what's happening is this command is telling Docker to map my computer's port to the 3000 to the container's port 3000. And so what I could do is like I could change 3000 to 3030. And so this is saying map my computer's port 3030 to the container's port 3000. And if we run this, we'll see the application still launches with port 3000 because this is the port we specified when we built the image. And the image, or the Docker file used that build parameter to create the image, and then we're just running that image. The computer is listening on port 3030. And so if we try to hit 3000, we're not going to be able to connect to anything because nothing on my computer is listening on port 3000. But there is something listening on port 3030, which is forwarding it to the container, which is listening on 3000.
Right. Right.
Hopefully that makes sense.
Yeah, and if I don't know if anybody was paying like super close attention a few weeks ago when Farron was kind of like showing Docker Compose and kind of how his app was bootstrapped. The same kind of port forwarding, kind of port exposing process was being done. And so that's kind of a very important step that people oftentimes forget. They're like, oh, how do I communicate to my containers? How do I? They're running. I just can't talk to them. And it's because you forgot that one little thing to do that. So
Yeah.
it's very, very, very common.
Yeah. Well, one thing I sometimes see is that so sometimes you don't like have the port specified as a build parameter. That was just kind of contrived for this demo, but you'll like your app will main will be hard coded to like listen to some specific port, and then in the Docker file someone will write expose 33,000.
Right.
That's the number I put here. Now, like expose, one thing people think this does, like you might think it exposes port 3000, but it actually doesn't do anything. It's just more documentation, such that someone else coming along will just see ports like expose 3000, and it's meant to tell them like the application is listening on port 3000. But we could just as easily like run this on 9000 and go through this all again without the build parameter. Oh, sorry, I'm in the wrong. This may take a little longer than intended, but it's rebuilding. Set the app at 9000, I believe. So like in our Docker file, it's saying expose 3000, but this isn't really doing anything. It's more documentation. And so if we run, like our app is running on port 9000, and because we've set this port mapping here, we can still hit the application on port 9000. That's kind of like a tangent, but something that kind of comes up.
It throws people off. Yeah, I definitely ran into that problem when I was trying to expose the port. I was like, oh, this is great. I'll just put it in my Docker file. But you don't put in your Docker file. You have to, it's higher than that. All right, so why don't we handle some questions? There's a few questions that got answered within the chat. I think a few of them are getting still handled within the chat. But one of them is each container essentially just a virtual machine?
Yeah. I knew this question would come up, and I almost put a slide in for it. So the difference between containers and virtual machines is just that, a virtual machine is a virtual machine. It virtualizes the underlying hardware, basically. And a container doesn't go that deep. It basically virtualizes the operating system layer. And so what tends to happen is like, while they're very similar in concept and you can actually use them to do a lot of the same stuff, a container tends to be much lighter weight and much smaller, and tends to be like faster and easier to handle than a virtual machine because it isn't utilizing like so much of the stack, if that makes sense.
Yep. Alrighty. There's a question about How do the ports work? Are there certain, oh, that's a deep question. Are there certain port numbers that we are specifically supposed to connect to?
No, not really. There is a protected range of ports at the lower numbers, and I forget exactly where the cutoff is, but you need like, I think sudo permissions to listen on those ports, or like run applications listening on those ports. At higher ranges, like 3000, 8080, it goes, the port, I don't know the exact port range, but it goes really high, like tens of thousands, and you can use all the ports on your computer. You might probably run out of memory before you run out of ports, I would expect.
Yep. All right, let's see if there are any other questions here. There was one that was about combining images, but I think that was answered in the chat. But the question was, can you combine images? For example, if I want to run MySQL and Go in the same container, could I do that?
Can you combine it? Yeah, yeah. So one thing I didn't really do is like download anything in this this Docker file. Like I didn't tell Docker to download anything when building the image, because everything I needed, the Go programming language, was downloaded from this image definition. And we can actually look at what this looks like. I don't think this is the exact version I'm using, but it looks something like this. it's installing Go. Yeah, this is like, this itself is built off another image, but it's more or less installing Go such that like I don't have to worry about it.
Yeah, I think there's a few questions that I think are that I think people are a little bit confused by. So when technically you can put like you can have MySQL and Go running in the same container, but oftentimes what people do is they'll have them running in different containers. So I think the comment from Sebastian in the comments was that you should use Docker Compose if you're running it locally, and that's oftentimes the preferred way of doing it. And so yes, I mean, I don't know if there's another question, like, can you run containers within containers? I feel I don't know the answer to that question because I've never tried doing something. I think that would actually, that doesn't sound like a good thing to do. Ideally, what you want to do is you want to have multiple containers running on the same host computer. So that's usually if you're going to do it locally. And so that's kind of what, just kind of a little bit more context there.
So because DBs are hosted separately, yeah, typically I mean, it depends on what your setup is and like the scale, but yeah, typically your databases will be on different things than actual like web servers, because they tend to scale differently.
Right, right.
I think you can run a container in a container, but it's not, other than for like academic or exploratory purposes, I don't think there'd be any practical benefit to that. There was this, funny enough, like post on Hacker News about running all of OS X, like the Mac operating system, in Docker, in a Docker container. I haven't taken a deep look at this, but I just kind of saw it before giving this talk and thought it was kind of funny.
Yeah, there's a question about what does Kubernetes do?
Yeah, so I haven't worked a whole lot with Kubernetes, but as I understand it, the main benefit of it is that, say you have all these images, and you have a bunch of like servers that you want to deploy instances of your application to. Kubernetes is software that allows you to more easily sort of deploy your application to those servers from these images. That's how I understand it, but I haven't worked very closely with it, so someone else might have a better description.
Yeah, I don't have a great, I haven't worked with it either, but yeah, I think maybe at a really high level, it's just like, if you have, again, it's like scaling up and kind of reducing the number of images you have. The big word there is orchestration. So if you just think about your entire a fleet of whatever, all the images, all the services you're running, then it kind of can scale and manage all of that for you. And you can think at very high level terms, but don't have to kind of manually just kind of change everything yourself. All right, so we are now, I think, at a good stopping point for questions on Docker. I know it's a very rich topic, so there's a lot of things that we could get into, and we can bring that over into the chat. But for now, we will just kind of pause that. Let's give Nick a big thank you. So again, you only hear me clapping, but I'm just gonna do that real quick. Thank you, Nick, for that. And then now we will start with demos. So a little bit later than usual, a lot of good content today. But so does anybody want to demo and just share progress from what they're working on? So it looks like there is a one person has a demo, and we can start with that. So is it Ken? Ken, if you want to demo, we can start with you, and then anybody else who wants to demo can go right after. And so we'll move on to demos.
Hello?
Hey, yep, we can hear you.
Perfect. So let me do you see my two browser screens there?
Yes.
Oh, sorry, 1 second. So my project that I started working on this month was to make a Discord bot. So I play video games a lot, and I very commonly, search for information online, and I found that it was a bit time confusing. I figured I'd just make a bot to just simplify and make things easier. So on my right side here, I just have a list of things that are available, and on the left side is just the Discord channel that is on my server and the bot that's available. So I have made a command. So here are the existing commands that I created. So I have primarily the feature to search things up in the website is hero. So for example, if I wanted to search Broodmother, for example, I would just type in !hero. And then it would pop up the two websites I would most commonly use at all times. So that included a lot of understanding strings and parsing links just to make sure that things work correctly and as per my expectation. The second thing I did also was to create a profile for each person, just to see what people play with at all times. So I was able to hook that up to a database. So let me just move this down a little bit. So this Dotabot is hooked up to MongoDB. So I'm able to store all this profile information onto MongoDB, which is a cloud-based database. So in this example I have here, so I'm gonna do, right, and then I have a message showing me that it's registered. So if I refresh my page here, see I am now registered, and I have here a list of arrays. I can still add things. So let's just say I like doing, and then I have here, I have on the backend side, I also have a lot of list comparisons to the existing Steam API, just to make sure that everything you're typing in is not gibberish or it matches to their database. And we can see that it's already in there also. And then, so let's just say I want to remove myself from this system. So I got to go back to my actual Discord thing. And it's gone. So yeah, so that's my demo of making a Discord bot.
Hey, Ken, can you talk about where the bot lives?
Where the bot lives?
Yeah.
I think to my understanding, it lives on the Discord server itself. Because all I did was I just took a Discord API key, and then it hosts itself. I just had to invite the Discord bot into my own server. So based on my understanding, it's hosted by Discord.
Gotcha.
That's my understanding of it.
Gotcha. And what part of your code does the writing to the MongoDB?
Yeah, let me just move my other screen here. Wait, how do I change screens?
I think in order to change sharing screens, you have to stop sharing and then choose a different screen to share.
Uh, okay, let me see if I can just drag my VM in here.
Oh, yep, that works.
Okay, so the question was, how did I connect it to MongoDB?
Well, how does the bot kind of trigger the saving to MongoDB and all that stuff?
All right, so I have here, that's not listed on my GitHub. I have an API key here.
Yep.
So I just followed a tutorial on MongoDB and just made sure that I have my Discord API key in there, and then it would link up to the password or like my MongoDB account.
Okay.
That's what I did. Right.
Yep.
And it was a little bit confusing because like MongoDB it's like a general service, and then it applies to different languages also. So I had to use the PyMongo version because I'm using Python. And it was just a little bit confusing trying to make sure that you had the right services set up, because I had to install this asynchronous client called Motor also, and this UV loop thing to try to make things run faster also. So that was a little bit confusing. I had to get someone else to help me with that.
Gotcha. And so this code is living on the Discord servers, or
Oh, right now I'm only running it locally for now. I haven't really like
gotcha.
Yeah, okay, I'm sorry. Then maybe that was, so I think later on I could probably like host it on like a server or like a service for Heroku or something, for example. But as of now, everything is run locally right now. As you can see in my terminal down here.
Gotcha. Sweet. Okay. And I guess one last question is like, so when the Discord bot kind of wakes up, how does it like talk to your local server, or is it all like a local Discord?
So I think it's all local Discord for now, because all my commands are using this async feature. So it just sits there and waits. So because if I cancel my terminal right now, and if I go here, my Dotabot, this thing here should disappear. And then once that's gone, nothing really works, right?
Yeah.
Until I start this up again. Once I get that up running again,
then
this will come back up, and then everything will work. And then async, to my understanding of what async is, just that it just waits for like all these commands like await and async. My understanding is just that it just waits for a response to come in before it like starts going into the code to get you what you want.
Yeah, it's essentially listening on the port. You have a little web server, I believe.
Yes.
Alrighty, cool. I think there were a few other questions, but I was asking some questions, so I think we got some of those. There's a question: is it running in a VM at all, or is that how that's working?
Oh, so what? Okay, so that's a bit confusing because Nick was teaching Docker and stuff. So what's actually happening is that I'm trying to learn Linux, so my development environment is all running on a Linux VM, and I was the one who asked about running Docker and VMs at the same time. That's why I couldn't get it working before. So, so the short answer is that it could run on any. It's just running off the terminal in my VS Code. That's all it's doing.
Gotcha.
All right.
Cool. Alrighty. Well, thank you, Ken, for sharing that. We'll give Ken a round of applause and seeing how the Discord bot works, which is kind of timely because we have a Discord bot that we rely on that is out of memory and has been causing me all sorts of grief in our Discord. So if you haven't been able to get your role, that's because of Reaction Rule bot is down, and it's quite sad. But thank you, Ken. Alrighty, and you're getting a bunch of claps right now, so that's super exciting. Let's see if does anybody else want to do a demo today. I wasn't following along in the Discord, so if you already previously posted that you want to do a demo, please post again, just because I didn't see that. So Theodora has some calendar features. So hey, let's turn it over to Theodora, and we'll give her a chance to demo. And yeah, Ken, if you can stop sharing your screen, then it'll allow her to do hers.
Oh, how do I do that? I just see pause share and resume share. I don't know how to. Oh, never mind. Got it.
Cool.
Can you hear me, guys? I need to talk a little bit, like with my voice low, because somebody's sleeping in the other room.
Yeah, it's late over there. So, yeah, but go ahead. Go ahead.
Can you hear me well?
Yes, I can hear you great.
Okay, I'm gonna share my screen. Okay, so for those who don't know about my app, I'm working on an application that allows students to track their progress during academic year. And at the moment, I'm working on the calendar features, which hopefully will allow the student to manage better their time. So it's been a very long road because I had the calendar implemented and from another person from GitHub, and I couldn't understand the code. I have no idea how he wrote C#, but even with help, I couldn't get it. So I got a license with a framework called Syncfusion. They had lots of functionality to Xamarin, and I think this time it's gonna work. So this is just like a normal calendar, flip right and left to go to another month. When you have events, you have these little dots, which announce you that in that day something's gonna happen. Okay, if you press on an event, it's gonna give you the long description of wherever. For example, if you have a maths test and you want to write, some subjects that you need to learn, you can just press OK and this will close, or if you press delete, it's gonna delete the event. It's just announced you that it had deleted the event. You can actually see here in the database how things are happening in real time.
Mm-hmm.
So I can add another event. I'm gonna call this SOS. The description is, this is an SOS demo. By default, it's gonna give you another hour for the event. So basically the event is long as an hour, but you can customize that, it's no problem. You can change it to, I don't know, another time, another date. For example, it's gonna be 2 days long. Okay, and when you press save, it adds it to the database and into the calendar.
Very cool.
Now, I want to you can see it like it's on 2 days if you see it, or actually more days. I don't know how many I selected. You can actually see in the database. So it's from the 12th to the 29th. Okay, that's very long. You can see it added a dot to each the dates that it's happening, and if you want to delete it, it just deletes it from there. Now I want to customize it and make it with colors and stuff, but it was so hard. So this is all the progress I have at the moment.
That's super cool. So you were able to, the big part of this was getting a library that you didn't really know how to work with, and then having it work with everything else in terms of just kind of updating that code to make it work the way you wanted to work.
Yeah, exactly. Now I'm happy with this calendar. I would be happier if I could implement the Google Calendar, but that was a little bit too difficult for me in this moment in time.
Gotcha.
So yeah, kind of that's it. That's the new feature that I have, and hopefully more for next week.
That's awesome. Well, thank you, Theodora. Hey, you have one question, which is somebody asked why is Xamarin over something like React Native, or maybe like they didn't ask it, but maybe Flutter, or kind of just what was the background behind that decision? And yeah, you're getting a bunch of claps right now, but the last one question before you go.
So first of all, I'm ashamed to say this, but I hate JavaScript. I don't like it. I like all the backend languages like Java and Python and C# and C++. I hate JavaScript. So I was looking around and I find Xamarin, which allows you to build the app once using C#, and it's going to be compatible with all platforms, iOS, Android, Windows, and so on. So I think this is really cool because you put the work into once and you can just share it to all the platforms.
Awesome. Thank you. All right. Well, thank you, Theodora. We will give you another quick little round of applause.
Thank you so much.
And yeah. Oh, and somebody is just asking, maybe you already mentioned this, but what is Firebase doing for the app? And I think just overall, it's just adding the persistence on the cloud. so that if you switch
Yeah.
devices, you can still log in and see all your data.
Yeah, exactly.
Awesome. All right.
Okay, thank you so much.
Thanks, Theodora. All right, is there anybody else that wants to do a demo tonight? Let's see. Any other demos today? Okay, so Jacob's got a demo that he would like to share, some progress that he's made. So whenever you're ready, the screen is ready for you to be shared on.
Sweet. Can you guys hear me?
Yes.
Sweet. So this is a project I've been working after I learned some of the ASP.NET and Angular.
Nice.
This is just kind of like to solidify some of the stuff I've learned from it over the course. And right now you can log in, register, and it actually gets uploaded to a database and everything. So what's a good name? Zusuka. And then you can also do a password, and it logs you in after you register and everything. And right now I don't really have a home page ready, but of the things I do have ready, I do have a profile page that you can go to. You can leave a comment on other people's pages and say hello, and it adds it to this little comment box. And then I don't have a user kind of search right now, but for now you can go to another person's page, say hey, you can add it to theirs as well. And you can also look at some of the posts that I have been making. And I don't have it yet, but you can add likes or dislikes, you can comment. Later I'm going to make it to where if you click on it, it'll enlarge. And then if you go back to your profile, you can also upload your own photos. So I can upload all these, and it'll just go through and it'll start adding them onto your posting page.
Yeah.
Yeah, so it's just like a really simple app. What I had in mind was I wanted to just share pictures, and I wanted people to interact with each other, and I wanted there to be like some kind of like main repository just to kind of view these images. So I just took a page from Tinder, and if you do right on the keyboard, like a right arrow, it's basically like swiping right, swipe left. You can dislike
That's awesome. Yeah.
But yeah.
Awesome. Dude, yeah, you're getting a lot of comments right now. People are like, hey, very nice design. Love the UI. Love little pop-ups and stuff. So.
Yeah, it was a really cool package called Itsy Toast. It's kind of like Alertify, if you ever used that, but it's a really slick kind of package I used for that. But
nice.
Yeah,
sweet.
That's all I got so far. Yeah.
Well, thank you, Jacob. Yeah. Let's give him a quick round of applause. And that's awesome. Like you're just sharing some progress, but that's a lot of progress. So, yeah, thank you.
All right, cool.
Does anybody else want to do a demo tonight before we kind of just break out into our just little breakout sessions? Any progress to share or something like that? All righty. Well, I think we'll just wrap it up at this point then. And we'll stop the recording and then kind of just move into that breakout sessions. And we'll move from there. So let me stop the recording.